Artificial intelligence, or AI, is a rapidly growing field that involves creating intelligent machines. These machines can perform tasks that typically require human intelligence. We encounter AI in our daily lives more than we realize. From self-driving cars to virtual assistants like Siri and Alexa, AI is already shaping our world. This essay aims to demystify AI by breaking down its core components and explaining how they work together. We will delve into the fascinating world of machine learning, computer vision, natural language processing, and more. By understanding these building blocks, we can gain a deeper appreciation for the power and potential of AI. The journey into understanding AI begins with understanding its basic components. Each of these components plays a crucial role in enabling machines to mimic human intelligence. By exploring these components, we can begin to grasp the complexity and capability of AI systems. In the following sections, we will explore the key components of AI, uncover the mechanisms behind their functionality, and examine the impact of AI on various aspects of our lives. At its heart, AI is powered by a combination of interconnected components. These components work together to enable machines to process information, learn from data, and make decisions. Machine learning is the engine of AI, allowing machines to learn from data without explicit programming. Imagine a computer program that can learn to identify different types of flowers by analyzing thousands of images. That's machine learning in action. Computer vision gives machines the ability to see and interpret images and videos. This technology is used in self-driving cars to navigate roads and detect obstacles. It's also used in healthcare to analyze medical images and assist doctors in making diagnoses. Natural language processing, or NLP, enables machines to understand and communicate with humans using natural language. Think of chatbots that can answer your questions, or virtual assistants that can understand your voice commands. Neural networks are a type of machine learning model inspired by the structure of the human brain. They consist of interconnected nodes that process information, allowing AI systems to learn complex patterns and make predictions. Reinforcement learning is a type of machine learning where an AI agent learns by interacting with its environment and receiving rewards or penalties for its actions. This is how AI systems learn to play games and solve complex problems through trial and error. Ethical AI focuses on ensuring that AI systems are developed and used responsibly, ethically, and fairly. As AI becomes more powerful, it's crucial to consider its potential impact on society and establish guidelines for its ethical development and deployment. These core components work together to power the AI systems we interact with every day. Understanding their individual roles is key to comprehending the capabilities and limitations of AI as a whole. AI systems, unlike traditional computer programs, are designed to learn and adapt. They don't rely solely on pre-programmed instructions. Instead, they use data to identify patterns, make predictions, and improve their performance over time. Imagine teaching a child to ride a bike. You wouldn't give them a step-by-step manual. Instead, you'd let them practice, fall, and learn from their mistakes. Similarly, AI systems learn through a process of trial and error, guided by data and algorithms. The learning process of an AI system involves feeding it vast amounts of data, which could be anything from images and text to sensor readings and financial transactions. The AI system then uses algorithms to analyze this data, identify patterns, and build models that represent the relationships within the data. Once trained on a data set, the AI system can then make predictions or decisions on new, unseen data. For example, an AI system trained on thousands of images of cats and dogs can then be used to classify new images as either cat or dog with a high degree of accuracy. The beauty of AI lies in its ability to learn and improve over time. As it encounters more data and receives feedback on its predictions, the AI system can refine its models, becoming more accurate and efficient in its tasks. Section 4, Machine Learning, the engine of AI. Machine learning is a core component of AI that empowers machines to learn from data without being explicitly pre-programmed. It's the driving force behind many AI applications we use today, from personalized recommendations to spam filtering and fraud detection. At its essence, machine learning involves training algorithms on datasets to enable them to make predictions or decisions without human intervention. These algorithms learn patterns and relationships within the data, allowing them to generalize their knowledge to new unseen data. The workflow of machine learning typically involves several steps. First, data collection, gathering relevant data for the task at hand. For example, if you want to build an AI system to identify different types of birds, you'd need a data set of images labeled with the corresponding bird species. Next, data pre-processing, cleaning and preparing the data for training the machine learning model. This may involve handling missing values, dealing with outliers, and transforming the data into a suitable format for the algorithm. Then, model training, feeding the pre-processed data into a chosen machine learning algorithm to train the model. The algorithm learns patterns and relationships within the data, building a model that captures this knowledge. After that, model evaluation, assessing the performance of the trained model on a separate dataset that was not used during training. This helps ensure that the model can generalize well to new, unseen data. Finally, prediction, using the trained model to make predictions or decisions on new data. For example, the bird identification model can now be used to classify new bird images. Machine learning provides a powerful framework for building AI systems that can learn and adapt from data, making it an essential tool in the development of intelligent machines. Section 5. Different ways machines learn. Within the realm of machine learning, there are various approaches to training algorithms, each with its strengths and weaknesses. These approaches determine how the algorithm learns from data and makes predictions. Supervised learning is like learning with a teacher. The algorithm is provided with labeled data, meaning each data point is tagged with the correct output. Imagine showing a child flashcards with pictures of animals and their names. That's supervised learning. The algorithm learns to map inputs to outputs based on the provided examples, enabling it to predict the output for new, unseen inputs. Unsupervised learning is like learning without a teacher. The algorithm is given unlabeled data and tasked with finding patterns and structures within the data on its own. Think of it like sorting a box of Legos by color and size without any instructions. Unsupervised learning is useful for tasks such as clustering, where the goal is to group similar data points together, and dimensionality reduction, where the goal is to simplify the data while preserving its essential information. Reinforcement learning is like learning by trial and error. The algorithm learns by interacting with its environment and receiving rewards or penalties for its actions. It's similar to training a dog with treats and praise. The algorithm aims to maximize its rewards over time by learning the best actions to take in different situations. The choice of which machine learning approach to use depends on the specific task at hand and the nature of the available data. Each approach offers a unique way for machines to learn and adapt, contributing to the diverse capabilities of AI.